Welcome back, everyone. Now we're going to have our final metamorphic rock lesson, and let's pick up where we left off. Now, you remember there was regional metamorphism, which involved intense pressure with a little heat thrown in, and there was also contact metamorphism, which was just pure heat changing the rock. But now let's talk about some of the changes that the rock actually undergoes when it's being metamorphosed and recrystallized. Now, the first thing that you need to remember is that density should increase a little, because if you squeeze something enough, the particles are going to get a little closer together. Now, what happens then is you're going to get a slight degree of what is called foliation, which means the minerals begin to align with each other. And now the rock starts to become a little bit flaky, kind of, because of the alignment of the minerals. And then what happens as you get even more metamorphism occurring, as it metamorphoses even more, because there are different levels of metamorphism. If you metamorphose it further, you get sort of like a moderate foliation, which is kind of like a sparkly, shiny kind of flakiness in the rock. And if you've ever driven the highways, looked out the window and seen some of the rocks sparkling in the sun, that would be an example of this. And then finally, the highest level of foliation and metamorphism is exhibited by a rock called gneiss, and that exhibits what's called banding. Now, this is the highest degree of foliation and metamorphism is the banding. So look at the diagram below. You start with the sedimentary rock shale. Metamorphose it slightly, and you'll get slate. Slate very much resembles shale. Sometimes they're hard to tell apart, but you do get a little more density in the slate, and it can be just a little shinier. So you're getting a slight degree of foliation. Then, if you metamorphose it further, you're now going to get more of that sparkly kind of foliation, what you get with a rock known as schist. And then, the highest level of metamorphism is exhibited by the banding that you see in gneiss. So gneiss is a really good-looking rock with that banding that goes on right there. Let me show you a couple of images. So here we have the ESRT interactive. So slate, well, it looks kind of like the original shale that it came from. A little bit tough to tell apart. But notice the schist, which is more metamorphosed, has that sparkly look to it. But gneiss, which is the highest degree of metamorphism, has that wonderful striping kind of a look, that banding and that striping, which makes it really a gorgeous rock. Okay. Now, so these are foliated rocks, all right? Now, I do want to point out, though, that what happens is we have foliated rocks, like the ones we just described, but we also have non-foliated rocks. Now, the non-foliated rocks, well, they're pretty much going to be monomineralic for the most part. You're not going to get different minerals lining up because the minerals are all pretty much the same. So they're going to look pretty much the same throughout. The marble sort of resembles the limestone. It's just a little more sparkly, or a little more like a gemstone, a little clearer. That's the quartzite, which is on top. Very boring looking rock, but you don't see layers or flakes or anything like that. Marble resembles the limestone that it came from. And the metaconglomerate does resemble the conglomerate that it came from. It's just that the pebbles are distorted now. But you don't get those distinct lining up that you get with the foliated ones. So these non-foliated ones are a little more homogeneous, is the word that I would use. Okay, let's continue a little further. Here's an example of the foliation of gneiss. So we start with granite, and you can see you've got your potassium feldspar, you've got your plagioclase feldspar, or maybe you got some quartz crystals in here, some black biotite. Now look what happens when it gets squeezed under enough pressure. Now, look at that. It creates a striping look, actually a gorgeous striping look. So gneiss is really a very beautiful rock, but you can see it does kind of resemble the granite that it came from a little bit. Okay, let's go a little further now. And let's classify. All right, so if the rock has banding, flakes, stripes, something like that, that's going to be the foliated ones. So it's separating of the minerals into distinct rows, distinct flakes, that's your foliated. It takes different minerals to line up with each other. Okay, now that it can form, bands. It can form, also you get distortion. See the bending and the distortion in this rock right here? And the other kind that I showed you was the non-foliated. So it doesn't have those bands, it doesn't have those flakes, it doesn't have anything like that. So it tends to be rather homogeneous, even throughout. Okay, so far so good. Now we are going to take a look at the ESRT. We're going to summarize the information here in this table. So slate, schist, and gneiss would all be examples of foliated metamorphic rock. Marble, quartzite, and anthracite coal would all be examples of non-foliated metamorphic rock. So now, let's go and take a look at slate. The parent rock is shale. All right, schist, well, the parent rock, if you remember the last page, that would be actually caused by further metamorphism of the slate. The slate gets metamorphosed further into the schist. And gneiss can come from a lot of things, including granite or schist. Now, a little help from you. Back in the ESRT, page 7 bottom, what is the parent rock of marble? Please enter your answer right here. Marble comes from what? And the answer is, marble comes from limestone. Once again, back to the ESRT, quartzite. The parent rock of quartzite, enter it right there. And your answer is sandstone. And this one's not going to be very challenging. What is the parent rock of anthracite coal? And the answer to that is the sedimentary rock known as bituminous coal. All right, next thing. Let's look at these parent rocks. What type of rock was the parent rock? So please indicate what type of rock the parent rock was in these cases. I'll give you this one. Gneiss can be either igneous or metamorphic. Let's see you enter the rest of these parent rocks in here. Okay, first, slate. Slate comes from shale, and shale is sedimentary. All right, schist. Schist comes from slate. Slate is metamorphic. Marble comes from limestone, which was sedimentary. Quartzite comes from sandstone, and sandstone was sedimentary. And anthracite coal came from bituminous coal, which I told you a minute ago was also sedimentary. So the lesson here is that metamorphic rocks can come from any other kind of rock. Igneous rock can be metamorphosed, sedimentary rock can be metamorphosed, and other metamorphic rocks can be metamorphosed. Now, one more classic example is looking at the increased metamorphism of shale in the earth. Now, I'd like you to analyze this diagram. Look at it completely, because this is what earth science is all about. Analyze that diagram very, very carefully, and I'd like you to answer these 4 questions based on this diagram alone. Pause the video, record your answers. Okay, so what process appears to be beginning on this dotted line right here? On that dotted line, what process appears to be beginning right here? There's a sedimentary rock, there's a metamorphic, so the process beginning there should be metamorphism. Now, if you wanted to say recrystallization, I could accept that too. Now, which metamorphic rock is the least metamorphosed? Well, you can't say clay deposits or shale because that's not metamorphic rock. Your answer would be the least metamorphosed would be the slate. The most metamorphosed, follow it all the way down. Like I told you, the highest level of metamorphism would be gneiss. And now finally, which type of rock would form at a depth of 20 kilometers and a temperature of 800 degrees Celsius? Well, 20 kilometers is along this line right here. 800 is along this line right here. They meet right there in the melting zone. So what type of rock would form from something that was in the melting zone? Well, it's not going to be metamorphic. It's going to be igneous. Igneous comes from melted material. So once we cross into this zone here, once the heat and pressure is too much and we enter this zone here, we're no longer going to make a metamorphic rock. We're going to make an igneous rock. All right, tough stuff, but if you do this well on this, then you really know your metamorphic rocks. All right, thanks for paying such close attention. We'll leave a question at the end, and have a great day.